guys, it's Mrs. Monroe this morning. We're working on page 385. We're going to skip this part right here because I can't pull up page 384. But we do need to know about this bubble up here. It says, to be precise, you need to check that the words, numbers, symbols, and units you use are correct and that your calculations are correct. So today is about precision and double checking our work. So I'm going to go ahead and scroll on down. We're still working on bar graphs and picture graphs. But this is our last section of this topic. So down here it says be precise. Sorry. Derek is making a tile pattern that will be 30 inches long. So inches is going to be our label. The graph shows how many of each length of tile Derek has. He wants to use more than one of each length of tile in his pattern. Show one way to make the pattern. Okay, so before we answer the questions, let's go down here, or go over here and look at our bar graph. So first it says Derek's tiles, so it must be talking about what type of tiles that he has for this pattern. It says the number of tiles that he has and the types of tiles. So it looks like he has 7 of the 3-inch tiles and 2 of the 5-inch tiles and 4-inch, he has 6 of them. It's type of tiles, number of tiles, okay? So what given information will we use to solve? Well, first we're going to use that he wants a total of 30 inches, okay? So Derek wants to use a total of 30 inches, right? Then he also wants to use more than one of each length. And lastly, we need to know what type of tiles that Derek has. Be right back to you. Next it says, show and explain one way Derek could make the pattern. So remember we need 30 inches total. So just like we do on reach cart, we're going to put our total over here that we're trying to reach. We're trying to reach 30 inches. So let's start with our 4s. That's the biggest tile. Okay? And so if we count by 4s, we got 4, 8, 12, 16, 20, 24, 28, 32. Let's stop there. Okay? So let's look at our 8s over here. Can you see these over here? Let's do you just a little bit. Ooh, you can barely see them. There we go. Okay. So let's see if we use 20. That'll get rid of a lot of those inches really quick. So let's do that. Let's see if we can take 5 of our 4-inch tiles. And I get 20 inches, okay? And then let's subtract that from our total over here that we're working to get. Remember, we're trying to get to 0 just like we do when we're trying to earn our reach tickets for recess and we're all donating. When we get to 0, we get a recess. Let's try the same thing. Looks like Luke is trying to get hold of me, so I'll have to answer that here in just a second. All right, so the next thing that's coming up, let's look at let's go to the next tile. So we got 2 inches here. We still have to get to 10. So let's go on down to 3, okay? Because it's the next biggest one. So 3, 6, 9, 12. We only have to get to 10, but we got to use both tiles more than once. So let's try 2 of our 3-inch tiles. So that get us to 6. count up, 7, 8, 9, 10, that gives you 4 inches. Okay, and then we know 2, 4, 6, 2 times 2 inches would equal 4 inches. And that gets us to 0. That means we've made it. All right, but then it says show and explain. So now we have to explain how we did that. So you're just gonna write that in words. You're gonna say, Derek can use 5 of the 4-inch tiles, 2 of the 3-inch tiles, and 2 of the 2-inch tiles to have a 30-inch pattern. Okay? And so we've explained it. So today we're talking about precision, so we need to go back through and make sure that we've done everything correctly. So we have everything in inches, right? Our calculations are correct. 5 times 4 is 20, 5, 10, 15, 20. 2 times 3 is 6. 2 times 2 is 4. If I add these all up, they should give me 30. 20 plus 6, 26 plus 4 is 30. So I'm good there. Okay, so I've made sure that it's precise. Okay, let's go ahead and flip on over to the back. Okay. And we're looking at sketch types and pricing. Go ahead and erase all this. Let's go ahead and look at this picture graph over here while I'm erasing. If you look at the top, it says sketch types and pricing. So these are different types of sketches, and they have landscaping, which is $2, and animals sketches, I'm guessing, for $4, and portraits for $6. Okay? So I'm just going to write that over here to the side because later when I scroll, it's not going to be there. So landscape portraits equals $2 a piece, and there's 1, 2, 3, 4, 5, 6. 6 times 2 is 12 plus 1, so we have 13 of those. Animal pictures are $4, and we have, so sketches are 2 of these, so 2, 4, 6, 8 of those. And we have portraits are $10, and we have 2, 4, 6, 8, 10, 11. And let's look at the scale so we know how we figured that out. Because it says here, each rectangle equals 2 sketches in stock. Each half of a rectangle equals 1 sketch in stock. Remember, this is our scale, okay? So it says, how many sketches does Marta want for number 5? So let's look at our scenario now that we've looked at our chart so we can try to answer our reasoning question. It says, Marta has $50, okay, to spend on sketches. She wants to display them in an array, right? We know what an array looks like. She has 3 rows with 4 sketches in each row. Martha wants to include each type of sketch at least 2 times in her array. So when we're coming up with what she's going to buy at least 2 of each one. So how many sketches does Martha need? Well, up here it says she's making an array with 3 of 4. So we all know that array means we're going to multiply. So we're going to take 3 times 4. If you don't know those yet, you can do it by your multiples. 3, 6, 9, 12. You can count those out with our little cheat numbers. So 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. We're getting pretty good at our multiplication, so we might not need that much longer. Then the next question says, make sense and persevere. What's a good plan for solving this problem? Well, we know that Martha has $50 to spend, right? So I got my $50 here. And we know that we need at least 2 of each. So we're going to use a combination of these types to reach $50. So we're just gonna write that down. We're gonna write down, we will use a combination of sketches, or let's say sketch types. How about that? To spend $50 and have 12 sketches. Okay, so we need at least 12 sketches, or we need 12 sketches exactly, and spend no more than $50. Yeah, I'm gonna scroll a little bit so we can see the last of that. Okay, so now we're doing 7 and 8. Be precise, it says. Show one way Martha can buy sketches to make the array. Use math word symbols to explain. Okay, so we know that we need 12 of them. All right, I still left my stuff over here. Okay, so let's do, I like to start with the big amount. So we know we have $50 to spend. The biggest amount, I think you can see it over here, is portraits are $10. Okay, we know we need at least 2 of those. So let's just go ahead and spend $20. Okay, missed that, sorry. So number 7 here, we're gonna say, we're gonna buy 2 of the portraits for $10 each, and that'll be $20. Okay, so I got my $50, subtracting 20 for portraits, 0, 5 is 3, so I have $30 left. Okay, then my next thing is animal portraits, and they're $4 a piece. So 4, 8, 12, 16, 20, 24, 28, 32. Now we could use a different amount here, or different amounts here. I think the best thing to do is to go ahead and work to the 20, because that'll be easy to subtract, and then we have 2's left, $2. So let's do that. So let's buy 5 of our animals at $4 a piece, and that'll give us $20. And then subtract that out. Okay, we have $10 left to spend. Okay, that makes it real easy because we know kind of by 2's, 2, 4, 6, 8, 10. We can get 5 of the landscape portraits. $2 a piece. That gives us $10. Okay, and remember our book doesn't include tax. So if you were actually buying this, it says to be precise. So if you were actually buying this, you would have to include tax. Okay, but they don't do that in the book. So anyway, she must have some hidden money there for tax. Anyway, so we've spent the $50, and then we also have to make sure that we have 12 sketches. So I've got 5 plus 5 is 10, 11, 12. So I have 12. So it says use math words and symbols to explain. So we wrote out our information here, and I think we're good for that. Okay. You could write it out in sentence form if you wanted to, but I think we're good for that. Let's go ahead to number 8. It says use structure. Suppose Martha wants to make an array of 4 rows with 3 sketches in each. Would your answer still work, class? What property is this? What multiplication property is this? What property says I can flip my products or my factors and still get the same product? What problem says I can flip my factors and still get the same product, right? Commutative. Commutative property of multiplication states that we can flip the factors order factors order. And the product stays the same. Okay, there we go. And we're done with 7-5. Tomorrow we're going to be doing bills and coins. I'll probably go ahead and record that today so you'll have it for tomorrow. See you later.